Hey, how's it going? Guess I'm 3.5 minutes late to the competition, so whoops. Shouldn't have done this problem. Okay, let's see here. Contest. Okay, join now, yes. Oh, good, they have an easy problem again. Generate tag for video caption. You're given a string caption representing the caption for a video. The following actions must be performed in order to generate a valid tag for the video. Combine all words in the string into a single camel case string prefixed by a pound. A camel case string, I know what a camel case string is. Remove all characters that are not an English letter except the first. Truncate the result to a maximum of 100 characters. Okay. So... Okay, caption equals I dot lower for I in caption. Okay. I dot lower if I dot is alpha else space. And then join, so we're going to make a string out of that. Now, while two spaces are in caption, you know what, let's not call it caption. Let's not overwrite our original. So then C equals C dot replace two spaces. I don't know why I used a single quote, but whatever. Okay. Yeah, now we have C split equals... Well, now hold on. Remove all characters that are not an English letter except the first pound. I don't know how that works with the capitalization. I'm assuming I can do it as a pre-step, but I don't know. Maybe it'll fail. Maybe there'll be a word in inverted. It says caption consists of English letters and space. So what does this rule even mean? Well, whatever. My life just got simpler. So C dot split. Yeah. Dot strip. Let's put it here. All right. Yeah, so for I in range length CS, start from 1, we have to add the capitalizations in, so, oh my god, thank you. CS of I, what is it, title? CS of I dot, is it title? Yep. Alright. And then the concatenated equals join CS. Then we will pound. Then con equals con 0. That'll give us a length 100, right? Return con. Leetcode daily streak achieved. Leetcode daily streak achieved. Wish it would just tell me that it was right. Okay, looks good to me. Okay. 953 of 953 passed. Awesome. Okay, how do we... Next question. You're given an integer array nums. A special triplet is defined as a triplet of indices I, j, k, such that I is less than j is less than k is less than n, where n equals num.length. Nums of I equals nums j times 2. Nums of k equals nums j of times 2. All right. Return the total number of special triplets in the array. So I is j times 2, and then k is j times... Is this right? Oh, I thought it was going to be like 1, 2, 4. So there just has to be 2 k's? Interesting. This is fascinating. Okay, so we can just look at the centers. What are the values? Oh, 0 is an allowed value. That is going to be a special case. So let's just use a counter. We'll say C equals counter of nums. And then we can just look at the value, the middle value for j in range. Oh, no. Oh, this is not going to work. Okay, that's fine. Please copy the whole line. Okay, so C right, and then C left. And you know what? If we do it this way, then we won't need to treat 0 as a special number. So length of nums, right? And we're going to say n equals nums of j. So it's just our current index that we're looking at, right? And this is going to be an empty counter, and this is going to be a populated counter, because the stuff at the right we haven't looked at yet. So we will remove from the right like that. Okay, so I, j, k. So we need something that is half, or no, not half, double this on both sides. All right. Simple. Count on left equals C left of n. And then count on right. Hey, this is kind of fun. I like problems like this. C right of n, and then I think once we have extracted the count, then we can increment this one. Maybe it'd make more sense to do that later. Whatever, it doesn't matter. Okay, now the number of combinations are going to be however many are on the left times however many are on the right, because you can choose one of each, right? Total equals 0, and then we will say total plus equals not n, n times 2. Yes. Total plus equals count on left times count on right. And that should give us the total number of combinations, I think. So let's run it. 0, 1. Oh dear. Oh dear. Okay. So let's take a look here. See what in think we found the problem. Yeah, so 1, 1, 2. Sweet. Work. Oh no, 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 no. Well, what am I supposed to do with this? Okay. It passed over 1,000 test cases. Oh my god. Okay. You know what? No, I'm glad I figured it out. So, so we'll go total mod equals m, I guess. And then all right, 1121 of 1121 passed. Sweet. That was a dumb mistake. I shouldn't have gotten mad. You're given an integer array nums and an integer m. Return the maximum product of the first and last elements of any subsequence of nums of size m. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order. The maximum product of the first and last elements okay, so I just can't multiply things that are too close together. That's right. Because it's the first and last, which means there has to be things in the middle. So it's basically asking what is the maximum product, but there's this weird constraint thing. We just use like a simple slider. We would want the min and max on the right and left in case there are negatives, and we can make it bigger, we just can't make it smaller. This is sort of like the previous question in a way. Now, let's not dwell on that. Okay. So we're going to have left and we're going to have right. And we have to have at least one on the left and at least one on the right. So, integer m, and we can't touch the ones in the middle. So, I think this is going to be pretty silly. What are we going to call it? The blackout zone? How big can it be? Oh, yeah, we're going to have to do something sort of smart. So, C left equals counter. And then C right equals counter. Is this how we want to do this? Yeah, I think so. I think there's efficient ways to get the minimum and max out of the counter. So let's start off with just C right equals nums. So it's everything that we haven't looked at yet. And then we need to remove everything from the sliding thing. So if it's 2, then we need to get rid of 0, right? So we're going to say for I in range m minus 1, and I just want to make sure m is less than, like, yes. Okay, m minus 1. I'm trying to think here. C right of I minus equals 1 if C right of I equals 0. In other words, if we've removed the last one, then we need to delete the reference so that it doesn't appear in the list of keys. Now, in the middle, there's going to be this blackout zone, so we're going to have to figure out how to handle that, but I think we can do that. Okay, so we have gotten rid of m minus 1 items, which means the first thing on the right is the first available element after we have satisfied the minimum things on the left. And only the first thing is going to be on the left. So C left of nums of 0 plus equals 1. Or I could just say equals 1. No, plus equals 1 is fine. Whatever. It doesn't matter. It knows what it's doing. So, yeah. How do we want to do this? We will say for I in range, let's just say 1 to length nums, right? Because the sliding window, no, we have to stop before length nums. Because it's going to be like left, 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 and then untouchable middle, and then right, 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 right. Like that, right? Okay, and the length of this is m minus 2. So, if m were 2, then the length of this would be 0, and we would be able to use every possible index. That would be the same as just saying, what is the, what is the max? Okay. So, minus m minus 2, and I assume, how could m be length 1? Okay, you know what? I don't want to deal with these weird single cases. So if m equals 1, then return max of nums. Otherwise, if m equals 2, then there is no restriction. So you can just... Does it matter? Yeah, you could have it start and end anywhere, and if you wanted it the other way around, then the start and the end would just be inverted, so whatever. Then we would say nums.sort. And then we would say return max of nums 0 times, it is product, right? Yeah. Times nums 1. So the two most negative ones, and possibly the two most positive ones, right? There's no third case, is there? There. What if there were negatives and 0? I wasn't thinking about 0. So if 0 in nums, then m equals max 0, comma m. Maybe there's some weird case that I'm not thinking of. I don't really want to have to worry about that. So these are our two edge cases, and now we can only worry about cases where there is a gap in the middle where we can't consider it. So this is now valid again, because if m equals 2, then the length of this is 0, but that'll never happen. So there will always be at least one gap. All right, so we need to do the calculation before and after. Let's do the calculation. Okay, m equals negative, I don't know, negative 10 to the, 10th or something, I don't know. Very, very small number. And then we want to do calc, and there will be left and right and non-local m. Now we need to do every combination. All right. So if m is lesser than 0, and 0 in L or 0 in R, then m equals 0. Special case. I don't know if that matters, but whatever. Okay, now we would want the mins and the maxes, right? The two mins and the two maxes. Or the min and the max. I don't know what I'm doing. For I in, I don't know, min of L dot keys and max of L dot keys I feel like I'm looking at cases that I don't need to. And J in Y, are these tuples? They should be lists. Okay, so we're just going to look at every single combination, and then everybody's happy. Yeah, so m equals max of m, comma, I times j. Okay. So we will do the calculation before we begin, and then we will modify left and right, and then we will do it again. C dot left, C dot right. Okay, so this should probably be a comment. So now, in this case, we are going to be adding to the left. So C left of nums I plus equals 1. And we are going to be taking away from the right. So C right of, I need to not screw up this arithmetic. I plus what? So we just added this one, right? Let's say m is 3. That means that there's 1 in the middle. So plus 2. So I guess plus m minus 1? Okay, let's think about it. If m were 2, then there would be nothing in the middle. And we would want to decrement what we just added. This is not correct. Okay. So, yes, if m were equal to 2, let's just think of the most extreme case. 1, 2, 3, 4. So this is part of left. No, this is left, and then this is the one that we're adding. So I is equal to 1, right? And so we need to get rid of it from the right. M is equal to 2, so it's going to be, yes, yeah, that's right. And then if m were equal to 3, then there would be an extra one in here. So that would extend into the next one. Okay, I am really worried that I've screwed this up, but minus 2, I guess that's all I can do. So then just do calc and return m. Let's pray. Closing parentheses do not match opening parentheses. Parenthesis was never closed. Oh, I see what happened. Oh my God. Invalid syntax. Cannot access local variable j where it is not associated with a value. L. All right. Yeah. That ain't right. So let's take a look. Print C underscore left, C underscore right. Yeah. And then print nums of I, comma, C underscore left, C underscore right. Let's try to see what it's doing. M equals 1. Oh. M equals 1. What in the hell? In that case, it would have to be the same value. So that really is a special case. It's either positive or negative, so in this case, 0 doesn't influence. Okay, 81. 18? 18 ain't right, so m equals 3. So 3, this should go further. Am I breaking? Length of nums m equals 2. M minus equals 2. So it should have gone all the way okay, so 3, it made it here, and then it stopped. All right. So let's see. 1, 1, that is correct. And then... oh. That ain't supposed to be in there. We should have gotten rid of the 3. We didn't go far enough. Shouldn't it be minus 1? So 0, 1... 0, 1, 2. This was correct. For some reason, it's not deducting properly. Something odd is going on here. Oh my God. Did I do that anywhere else? I better make sure I didn't do that anywhere else. It doesn't look like I did. Okay, that one's correct. And then, so -5, +5, 6, and -4. And then it does properly add the 3. That is correct. But it doesn't look like it got rid of the -5. Did it get rid of something else? 5, 5, 6, -. What the hell? Nums of I plus m. What is m? M is 3. So let's go over here. 3. And then plus 3. So 1, 2, 3. Minus 2. 1, 2. That is exactly right. I didn't get rid of it like I was supposed to. Let's see here. Let's do this, because this is getting confusing. C right of x equals 0, then DL C right of x. No. positive I had copied that. Okay, X. Left, right, go. -4. Oh my God. Okay, that's actually kind of funny. All right. Max. Let's look for M equals. That's fine. Let's change these ones. So M equals. Next. All right. Min argument is an empty sequence. Are we going one too far? So let's see. We're getting rid of the -4, and we're not supposed to, which means this is going one too far. All right, 81, 20. What are you doing? 2, 1, 2. Oh, I did M equals 2. M equals 2 is a special case, right? Yeah. 35. Let's get rid of the print. And submit. Please work. Whoa, that is going slow. Interesting. M equals 4. And it was expecting the 9 to be multiplied by the 10. So 1, 2, 3. Yep, absolutely. That should have been permitted. Let's use the test case. This is expected 90. And I think we need the print statements back in here. Let's see what it does. Okay, why is the 9 and the 10 not appearing together? So, when we add the 9, we never add the 9. -9, 5, 6, 1, -2, 10, -8, 6. So yeah, we add the 6. 1, 2, 3, 4. That is correct. So there must be something wrong in our calculation here. So there should have been a time when there was a 10 and a 9, right? Be right here. Here's a 10 and here is a 9. L R min max min max. Print MA, no, don't do it like that. Print MA, comma, I, comma, J, I times J. This looks right to me. Something weird is going on here. 91, 91, 91, 91, 91. So we add the 10, right? Min and max. That's not the max key though. C left, C right. So we have added the 10. The 10 is here, the 9 is here. Why are we not using them? Oh, here's the 10. Here's the 10, and then what in the hell? And 9 is 90. Print MA. And 9. Look at that. It was 90 and then it got reset or something. Am I setting MA somewhere? Next. Am I confused about how non-local works or something? If MA is less than 0, print starting MA. Because obviously, if that's not storing the value, then starting MA very small. Starting MA 81, 81, 81, 81, 90. What in the hell? I am very confused right now. Results equals, I guess, like that. I don't know. Results equals set. And then MA results dot add I times J, I guess. Results dot add 0 if there is no MA anymore. Okay. Return max results, I guess. I have no idea what's going on. I thought I knew how to code, and apparently I don't. So, results. Okay. Is that going to get really, really big? Yeah. Okay. Let's do this. Results equals this. Results dot append. Results dot append. And then get rid of the print statements. Okay. Results dot sort while length of results is greater than 1. Results dot pop 0, I guess. Might not be the fastest solution, but I'm still printing. So 81, 20, 35, 90. Why am I still printing? It's just gotta pass the test cases. Time limit exceeded. Okay. This was dumb from the beginning. -1. Ten to the 10th or something. Alright. Then results of 0 equals max results of 0, comma 0. And then results dot 0 equals max results of 0, I times j. I think, I mean, this is speculation, but just something weird was going on with the global variable, so, or the non-local. I don't know what, but it doesn't matter. Results of 0. So let's see. Everything is a results of 0, right? Result 0, result 0, result 0. That should be faster. Now, if this is still too slow, then I don't really know what to do. Interesting. Well, that's just downright annoying. It must be really large. I can't use the test case. Maybe it's not efficiently maybe it's not efficiently removing the right and the left, or the min and the max from the counter. I thought that that was a really quick operation, and apparently, or maybe I was wrong. Okay. It only matters if it was the min or max, though. Okay, because we knew what the max on the right was to begin with, right? What am I doing? I think this is the slow operation. This and this. And I just need to speed it up enough. Okay. Left min max equals, well, okay. Let's do this here. Left, we don't need a C left. We don't. So left min max of 0 equals left min max of 0, comma num, oh my god, comma nums I. Like that. And then left min max of 1 is max of left min max of 1 and nums I. I'm curious if that would be fast enough. 90. I would like to get to the last question. Question is if it was even close. Damn. Okay. Okay. If the right min-max, let's do this. Right min-max. I think it's fast enough to do it once. Okay. Right min-max. Okay, yeah, only if we removed something and it was the min or the max, then do we need to do something. So if right min max of 0 equals x, then right min max, which is the min, right, equals min of L dot keys. No, R dot keys. Yeah. If right min max, I really hope this is good enough. Max of r.keys. Please be good enough. R is not defined. So we only do this if we zeroed something out. What the hell? I thought I got rid of them all. If this doesn't work, then we're going to have to do something with like a heap or something ridiculous. Oh yeah, this is starting to piss me off, actually. Something like just a big string of numbers, 1, 2, 3, 4, 5, 6, 7, 8, like that. Negative heap, positive heap. Well, at most, it could be the next value. And it's only if we got rid of the last one. No, 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 because we would have to... We would have to keep evaluating it. Yeah, we could do that. All right. Let's look at the last problem. This is getting ridiculous. Find weighted median node in tree. You're given an integer and an undirected weighted tree root noted at 0 with n nodes numbered 0 through n minus 1. This is represented as a 2D array edges of length n minus 1, where edges of I equals u, I, v, w. Indicates an edge from node ui to vi with weight I. The weighted median node is defined as the first node x on the path, such that the sum of the weights is greater than or equal to half of the total path weight. Yeah, you know what? I'm not going to figure this out in time. Pretty sure that's the last problem. So let's go back to problem number 3 here. Okay, yeah, I'm pretty sure we can do this once. Yeah. Min right heap equals what? Let's go nums.copy list of set of nums, min right heap, and then max right heap is going to be list of set of nums. Yeah, because we would never re-add something. We're just going to be taking away. So set of negative I for I in nums. Is that the max or is that not the max? Let's go heapify okay. And then assert min right heap of 0 equals right min max right min max of 0 and then max right heap. I think I did this exactly backwards, but that's what the assert is for. We're going to figure it out. Okay. Okay. Max right heap of 0. So this is the max, and this is the, well, this is the negative max. Yeah, right min max. If I in left min max, right min max. Okay. So, if right min max of 0 is not in R, then we have to do cleanup. If right min max of 1 is not in R, then we need to do cleanup on the max. So heap pop right min max, right? Let's do it like this. While right min max of 0 is not in R, heap pop right min max. If negative right min max of 1 is not in R, then heap pop of max right. No. There we go. Index out of range. Fuck. Okay. No, I should never get rid of the last one. Something is wrong. So max right heap is the negative ones, right? Max right heap 1. Oh. Equals min right heap of 0. And then equals max right heap of 0. Yes, that would be important now, wouldn't it? All right, 81, 20, 35, 90. Okay, if this doesn't work, I have a temper tantrum. So, okay, assertion error. That is not supposed to happen. Uh, 1, 3, 4, -5. Use test case. Let's take a look. Right min max. And then I really was expecting this to work. So which one failed? Okay, let's just label them. Show me the failure. Why? Okay, so max right heap is 4, -1, 3, idiot. Absolute imbecile. Okay. Expected -5, actual 5. Interesting. Yeah, that's not supposed to happen. So print left min max, right min max. Results 0. 1, 2, 3, 4. Yeah, there's absolutely no choice. Um, 1, 1, -5, 5. Where did the 5 come from? There's no positive 5. There was never a positive 5. And it only appears once. Well, I don't even understand where a positive 5 is coming from. There should have never been a positive 5. Max right heap. Yeah, but this should get rid of it if it's not in there. So it's on the right, it's getting a positive 5 in it somehow. That is bizarre. Print min max. That should not be happening. Here, let's do an initial cleanup. Yeah, not in. And then let's investigate. Min right heap. Right min max. Max right heap. There's no 5. Where the hell is it coming from? -5, 1. That is correct. Okay. It's right min max. Am I looking at the right thing? Max right heap. Is that it? List index out of range. This is the max right heap. It should be negative. This one shouldn't be negative. Oh my God. I think I need a drink after this. Okay. Next. Next. No, my code was legitimately wrong. Okay, if a heap is not fast enough, then I guess I'm hosed. I really thought a heap would be fast enough. I mean, a counter is like a hash, right? That should be order one lookup. Crazy. Well, I tried, so it's a little disappointing because I thought that this code would work. Let's see here. Like, I don't... Is this really necessary? I'm not sure that this is necessary. And then this is not going to make a difference. The min times the min and the max times the max. Is there a case where 0 is higher? Like if you're forcing a negative number to multiply by a positive, it's preferable to multiply it by 0. I don't know, actually. Okay. So maybe we can check it once. Yeah. Do calc. So if nums of 0 equals 0 or 0 in C right, then results equal, yeah. Results of 0 equals max results of 0, comma 0. And then we can also do that here. If nums of I equals 0, and results of 0 are less than 0, then yeah. I don't think this is going to make a difference, but you know, maybe if it was close. I don't think it's going to be close. Taking everything out of a heap I thought was pretty darn fast, but oh well, whatever. We've already reduced it and gotten rid of all of the duplicates. I thought this was a order 0 operation. Well, I am officially sad. I guess we're done here.